Our next speaker one time performed at an amateur comedy night at the Madison Comedy Club. Everyone, please welcome Tom.
So, hi everyone. My name is Tom Bliss. I hope everyone is a football fan because this is obviously our second football presentation. So I'm going to be talking about player movement in the NFL and how it's being used across sports. So what we use, like a new data source that we have at the NFL and again across all sports is called next-gen tracking data. Shout out Mike Band for that. But it's location data, it's XY coordinates, it's speed acceleration of all the players throughout the play. Again, it's new, improving. It's relatively recent that we had this data. It's only 2018 to present, and it's not just used in the NFL. It's used across all leagues. And so, on the bottom here we have an animation. Essentially, what you see is each dot there represents a player throughout a play for an NFL game, and you can see how the players are moving throughout the play and understand that they see the XY coordinates, see how fast they're going, see how much they're accelerating. It's a lot more information than we had previously. So yeah, as I was just saying, traditionally what we would have is just outcomes of plays, and for those of you who watch football, you would know it's a very start and stop game. You'll start at a certain state, and like we have information like, okay, you know the score, you know the down, you know the distance, you know where they are on the field, and then the next information you get is once the play is over. So what this tracking data is now we have everything that occurred within the play. And instead of just knowing, okay, this play was a touchdown, we know, oh, this receiver ran this route to get open for a touchdown. It's a lot, we've only had it recently, as I said on the previous slide, and it's a lot more data. So before it's about 150 rows per game, and now we're dealing with millions of rows per game, which as everyone here is a data scientist, they should know more data is a good thing. So it's used across a bunch of different sports for a bunch of different reasons. It's used for player evaluation. For example, you can figure out how fast the player is moving throughout a game. You can figure out whether the movement is causing some other thing on the opposing team. You can dig a lot deeper in that. Coaching strategy, of course, too. I read a paper recently, and it was on essentially using a deep learning model. They were able to mimic and this was in soccer, they were able to mimic what the opponent would do based on the positioning of their players. So you can use that to sort of figure out strategy and figure out what would make sense and how you could possibly use your players to get a certain response from the opponent. And then finally, player conditioning and health. I think that might be the obvious one in the sense that obviously you're thinking of speed, you're thinking of acceleration, you're thinking of, you can do a lot in terms of injury recovery, in terms of measuring how fast a player has been and whether they're increasing in speed, whether they're being overworked, whether they're not working enough. There's a lot we can do with this data, and teams and people everywhere are working with it, but I think we were just at the tip of the iceberg of everything we can do. So what do we do specifically at the NFL League office? So at the NFL League office, we're not necessarily interested in any particular team winning, but we're more interested in games being competitive, games being exciting. So I mean, yeah, despite some fans maybe disagreeing with that, but so we want exciting games, competitive games. We want games that are well officiated. We want games with fast pace of play. We don't want a bunch of stoppages. So we don't want long breaks where nothing is happening. And obviously we want we don't want to see players get injured. You want to see our top players able to play, and it's just bad for the game when players are getting injured. And again, we're the league office, so we can't tell a team, oh, you should run this play because it'll help you with injuries, or oh, you should run this play because you'll be able to score more and it'll be more competitive. The teams themselves make those decisions. So our avenues of influence are maybe to try to make the games as competitive, well officiated, increase health and safety. It's not necessarily controlling what the teams would do, but it's maybe other factors such as rule changes, as well as the team schedules, which is sort of determined by the clubs, broadcasters, and ultimately the NFL. So with all that, I'm going to give a sort of a toy example of how we can use the tracking data, combine that kind of with our goals, and like show what we can do before. So for this toy example, we're going to look at surface as well as, which is grass, field turf, sort of what the game is being played on, as well as the play clock. And the play clock is, for those of you who don't follow football, essentially there's a timer after one play ends before the next play has to start, or else you're going to get penalized. So those are the two things I'm going to analyze here. Again, I'm going to use the NGS tracking data, which I just described, and my methodology for this simple example, I'm just going to look at regression analysis. All right, so I've talked a lot about player movement. I mean, the talk is about player movement and player performance, but it's a very hard thing to define in the sense that, I mean, what is player performance? Is it how fast you're going? Is it how fast you're going at the end of the game once you're tired? Is it like there's a bunch of different ways to define like performance, athleticism. It's not a simple term. It's sort of a vague term. So we want to think about a way to define it. And in football, it's more complicated. It's about as complicated as you can get in the sense that a lot of the movement is dictated by how other players are moving, and a lot of the movement is you're trying to push somebody over. You're moving into somebody. So in that sense, a lot of the movement is sort of dissipated, and it's not easily measurable in the sense like with XY coordinates, because if two, like, they're not going to move very much when two players are in contact. It's unclear whether the player is unable to move because they're not trying to move or if they're being blocked. It gets very confusing really quickly. And I mean, yeah, as you can see this picture, like this is what a game might look like. You have players blocking each other, pushing into each other. There isn't really any clear place where you might have a player sprinting or some way where you can easily measure their ability. And in the sense that, like, if we were to use this, we would be missing data, we'd be missing information on what the player could do as opposed to what they did do. So what we decided to do here is look at sort of one situation within a game, and it's not super common in the sense that we have like a bunch of games and this occurs, but there's this route in the NFL called a go route, and a route meaning what the receiver will do in order to try to get open, to try to catch the pass. And in this case, the receivers will sprint downfield as fast as possible. And what we kind of realized was one of the rare places where there isn't quite this issue in terms of players running into each other is on this go route. And again, if we were to do another route, if we were to do like receivers running like a curved route or a route with a cut in it, that'd also be difficult because, again, they might not be running their full speed because they're anticipating some sort of curve or some sort of other quick movement. So that's why we're going to have to focus on that. Right here on the bottom left, we have an illustration. I think that's from Madden, for those of you who play Madden, but it's what it looks like. All the players are kind of running forward. And here on the right, this is a play from the 2020 season. If you look at the four players in white on the Denver Broncos in the bottom section, those players are running a streak route, and you can see they're sprinting forward. They're just sprinting forward. And again, opposed to all the blockers and the quarterback and everyone else who's kind of, their movement is very much tailored by everything else going on. So within this framework, what we decided to do is look at max sustained speed. And the reason we want to use sustained speed as opposed to just a straight max is we don't want to be susceptible to an outlier that sort of deters the pulls the data to a certain place that it's not. So we're looking over a 0.5 second interval, their max sustained speed. We're also filtering for some other things, such as making sure the quarterback had enough time, like the quarterback doesn't throw the ball immediately or get sacked immediately. So that way we're not overcounting anything. And we also want to wait. We want to do it before the ball's thrown, just in the sense that if there's some sort of tackle or some other sort of movement that might be influencing this, we want it to be focused only on the part of the field where the receivers are just running. So again, we're going to use max sustained speed on these routes, and that's going to sort of be our data set. It's about 8,000 from 2018 to 2022, so that's essentially 8,000 times a receiver ran that streak route and had ample time without the quarterback being tackled early or like the pass being thrown early. So for example, this play would have 4 observations. So the methodology here, we're not just going to use this like a ordinary linear regression. We're going to use a mixed effects model. And in sports, I think mixed effects models are really nice and really helpful. So a fixed effect model, that's something that we're probably all used to. If you just in R, if you just do LM, you're going to have a fixed effects model. And obviously, those work in a lot of cases. But in this situation, what we want to do is we want to take the variable that we're interested in this case, field surface or play clock, see how that, in addition to the effects from the player, have an effect on max sustained speed and model and look at that effect. So if we were to model like players as fixed effects, because obviously the fastest player and the slowest player is going to be a difference, so we don't want the model to just pick up on the difference between players. If we're going to model fixed effects, if we're going to measure players as fixed effects, we're going to add like 500 columns, which obviously from a complexity standpoint isn't really the way to do it. So the advantage of using a mixed model and using a random effect for player ID is instead of adding 500 variables, we're essentially adding the same complexity as one fixed effect variable and allowing the values to fluctuate. So the fastest receiver and the slowest receiver will have different values for a given player, but we also aren't making it overly complex. We're sort of assuming that all the players come from the same distribution, which is a good assumption in the sense that it's not like one of the players is like a cheetah and one of the players is a car and one of the players is a human being and one of the like they're all the same population, and obviously they're all NFL players, so it's already athletic, very top players. So that's the assumption we're doing here. And again, the variable of interest will still be a fixed effect, but the player ID, which will be a random effect, and we're going to take essentially the more observations we have, the more confident we'll be that this player is far away from average. But we're going to assume that all the players are from the same observation, and that way we can add them and not overfit the model. So to dig deeper into what these player effects actually look like, here's an example of the top 15 in terms of the player effects. So what you're seeing here on this chart, the y-axis are receivers, they're players that are in the data set. They're people that are sprinting. These are the top 15. The x-axis is the change in max sustained speed from an average receiver. So for example, like Brashad Perriman, he's the fastest. Deshaun Jackson's the second fastest. And if you take Deshaun Jackson, you compare him to an average receiver doing in the exact same situation on the same field doing the exact same thing, he's going to be about 1.4 miles per hour faster. So this is what the output looks like. And again, the advantage is we can have these differences, but we're not overfitting the model. And the standard deviation of the random effects was just a way to think about how important they are. Like if the top player and the bottom player aren't that different, the standard deviation will be small. But because they are different, it's non-zero, so it's about 0.7. And again, these are all for those of you who follow football, like a lot of these names are known as these fast, speedy, deep threat receivers. So it makes sense that we're seeing these names. All right, so I'm gonna first talk about surfaces. So I'm gonna go back essentially, we're fitting a mixed effects model. Max sustained speed is our y variable. The variable of interest, which in the first case will be surfaces, is that x variable, and then player ID remains a random effect. So if we were to do this, and we were to analyze the coefficients that we get here, so we're accounting for player differences, and we're just seeing how max sustained speed is affected. We get this chart, and the y-axis here are different types of surface, different types of grass / artificial turf. The top section there, the ones in the red box, those are all types of turf. I don't expect anyone to know the difference between them. I don't know the difference between them. They're just different turf, like slightly different material from each other. So I decided to differentiate them. Then like the x-axis here, that's change in max sustained speed from grass, and grass is our reference variable or reference layer here. So as you can see, Shaw Sports Momentum Pro seems to have a big effect on the biggest effect in a positive direction in terms of change in max speed from grass. And the lowest is grass / baseball diamond. And for those of you who maybe watch football, there was a team, the Oakland Raiders, who had a stadium in which part of they shared with a baseball team. So during some of the weeks of the season, there was like an outfield in the middle of the stadium, or in the middle of the field, which you can see up there. So that's what that is. And again, like we're somewhat involved in the field, like in terms of field surfaces, and this is something that the league can be involved in. And then the other thing that we have, the other thing that I'm going to talk about here is play clock. So again, play clock, that's the amount of time that you have to start to take the snap before you would get penalized. And that's like a player is tackled, a player goes out of bounds, and then you have 40 seconds before the offense is penalized if they don't snap the ball before then. So there have been suggestions to shorten this play clock, make it less, so that way maybe you're going to see more plays, it'll go faster. That's definitely been something that's been suggested. So in a way we can analyze this, and again, this is a simple example. We're really only looking at one component of player performance here, but a way to analyze this would be if we look at the time from the previous play, and then we look at how the max sustained speed will change based on that. We can see that there is a positive effect in the sense that if you have more time between the players are able to reach faster speeds, which intuitively makes a lot of sense. You're going to be less tired, you're going to be less exhausted. If you have more time to catch your breath before before play restarts. Again, maybe you're seeing the y-axis. It isn't that big of a difference. We're talking about 0.4 miles per hour, but it's non-zero, and maybe it wouldn't be if someone were to propose this rule, it wouldn't change everything, but it is something that we would want to take into account. So in terms of rule changes, obviously the NFL is involved in that process, so this is something that we can use and bring to the table. And I mean, this is kind of the case with a lot of things, but when it comes to rule changes, maybe shortening the play clock, you'll have less dead time, you'll have more time when the players are actually playing, but then you're going to have other effects, such as perhaps maybe the players aren't able to reach their peak performance as much. And again, we want the games to be as competitive as possible. We want to see the athletes doing everything they can. All right, so again, here are the results. Looking at in this example, surface clearly had an effect. I mean, we saw like some with an effect of about 0.8 miles per hour, and then we saw that baseball field around negative 0.8. So there definitely is an effect in terms of max speed reached, which is pretty intuitive. It makes sense. You're probably able to run a little bit faster depending on what surface, what material you're running through. Play clock, there was a smaller effect, but a non-zero effect. And again, from this analysis, we would come back and say, maybe shortening the play clock would help in some ways, but it wouldn't be the end. There would be a negative effect to it, possibly. And yeah, so that is my presentation. Thank you all for listening.
you.